Okay, AP Chem, here's a couple more assigning oxidation number problems with maybe a little bit more complicated of compounds and such. So let's start with this guy. This is potassium permanganate. The one in the middle is typically the one that we're not sure of. Not always, but typically. We do know that oxygen is at the end, and there's 4 of them, and we can count on him being a -2 in this situation. We know that potassium's in front. Potassium's an alkali metal. He's always +1. Manganese, however, is a variable charge metal. He can have lots of different charges. So you see that there's no number there. That means that it is a compound and is electrically neutral. So if I add up the +1 for potassium with the unknown for manganese, and then the 4 oxygens that are each -2, the total is going to be 0. So in this case, the oxidation state for manganese is +7. So potassium is +1, manganese is +7, and oxygen is -2. Let's do a polyatomic ion. This polyatomic ion is called oxalate. So we have oxygen in there, which we can count on being -2. And carbon's another one. We have 2 of them, but we don't know what the charge is going to be on him. Carbon can carry lots of different kinds of charges. So we're going to add up. This time, it's not going to add to 0. So when we add it up, it's going to add up to the charge on the polyatomic ion. Like such. So make sure you understand where all the numbers come from. So so in this case, the charge on carbon is +3, and the charge on oxygen is -2. Let's do another tricky one together. This is called aluminum perchlorate, like such. People often confuse aluminum. Aluminum is actually a fixed charge metal. But let's say I didn't remember that it was a fixed charge metal and that it has 3 valence electrons and then it always has a charge of +3. I can also look up perchlorate. It is all the halogens, when they form polyatomic ions, they form polyatomic ions that have a charge of -1. So anytime you have an oxyanion, meaning that oxygen with a polyatomic ion and it's got a chlorine or bromine or iodine in it, all of those have a charge of -1. So inside here is -1, and there's 3 of them. So that means that aluminum has to be +3, because these 3 perchlorates give me a charge of -3 in the back. But let's say that I go about it the way of, I know that perchlorate, so ClO4, has a charge of -1. I can do it this way. Then I can say that I don't know what chlorine is, but I do know that oxygen has a charge of -2, and there's 4 of them, and it equals the overall charge of the perchlorate ion. So it's X minus 8 equals -1. So chlorine in this case has a charge of +7. Or I can say this aluminum perchlorate here really means that there's 1 aluminum and 3 of these polyatomic ions, like such. That's what that really means. So I could say I know I have one aluminum that has a charge of +3. I know I have 3 chlorines that I don't know what the charge is. I know that I have 12 oxygens that have a charge of -2. And I know it's a compound, so it's electrically neutral. So +3 plus 3x minus 24 is equal to 0. So 3x is equal to 24 minus 3, or 21, and x is equal to +7. So you can see there's a couple different ways to get the one that I don't know. This is at top, what I did first is probably the easier way, but I'm just trying to show you 2 ways in case you do get a little bit confused. You'll get to the point where you'll see these numbers falling into place without even doing the math.